guys, in this video we're going to do some more solving exponential equations, and something really important to remember is we want to isolate the exponential before we take the log of both sides. And remember, the log base needs to match the exponential base because those are what are inverses of each other and are what are going to cancel each other out. So remember, log base 3 and an exponential base 3, right? That's really to the first if I wanted. Those are going to cancel each other out. The other way I can think about this is 3 to what power equals 3? Well, 3 to the first equals 3. Okay, so for example, if I wanted to take the log of this one, the exponential is already by itself. I want to get x by itself, so I want to get rid of this exponential of base 3. So we're going to apply log base 3 to both sides. Okay, so log base 3 of 3 is 1. I'm left with 1x equals log base 3 of 7. Okay, so this would be your exact answer. Now, on some of the assignment, it might say to, like you can see the directions down here, so give an exact and a decimal. This would be considered exact form. Some of your calculators, if I showed this to you guys in the 7-4 day 2 video, but some of your calculators, you're able to enter any log base. If you have that option, go for it. So some of you, this is an example of one that does not have log base. There's nothing in here. So what I'm going to do is I'm going to use the change of base formula, and I'm going to choose log base 10 because I have that button on my calculator. So I'm going to do log base 10 of 7. Remember, I don't have to write the subscript when it's log base 10, divided by log base 10 of 3. And then I can enter that in my calculator because I have just the common log button. Sorry, mine's kind of rubbed off right here. It's right next to the 7. So I'm going to do log of 7 divided by log of 3. And I'm going to round to 2 decimal places, so approximately 1.77. And that's, again, what those squiggle equal signs mean, is approximately, so approximately 1.77. So this would be the exact answer. This would be the rounded answer to 2 decimal places. Okay, so we did this a little bit in the last video, but we want to make sure that my bases match if I'm going to set the exponents equal. So I have 2 to the 4x plus 1. I can rewrite 8 using 2 because 8 is the same as 2 to the third. And then I have 3 times that already x value that was in the exponent. Once these match, now I can set the exponents equal. So I've got 4x plus 1 equals 3x. Get all my x's together. So we got 1 equals negative 1x, divide by negative 1. So negative 1 equals x. Now, obviously, that's a nice exact answer. I don't have to give 2 decimal places, okay? Okay, this one I need to isolate this log first. So I can't write 65 in terms of any log base, so I'm gonna just subtract 5. So we've got 10 to the x plus 4 equals 60. Again, 60 I can't write using a base of 10, so I'm going to go ahead and just take log of both sides, log base 10. So I've got log of 10 to the x plus 4 equals log of 60. Okay, so log and exponential base 10 cancel, and we're left with x plus 4 equals log of 60. And then I'm going to subtract 4 from both sides. So I want to be careful here. I don't want to do 60 minus 4. This 60 is log of 60 and then minus 4. So to kind of make sure we do that correctly, I'm going to put the 60 in parentheses to show that this is a term together, and then write the minus 4 on the end. So again, this would be my exact answer, and then my approximation is now I just enter that in the calculator. So I've got log of 60 and then minus 4. So approximately negative 2.22. Okay? All right. Next one. Okay, e to the 2x. That piece is what I would consider the exponential. So I need to get rid of the 6 and the 4 before applying a log. So I'm going to subtract 6 from both sides. So I have 4e to the 2x equals 5. Now I'm going to divide by 4. So I have e to the 2x equals 5/4. Okay, and now the opposite of e, right, is log base e, which is our natural log. So I'm going to take natural log of both sides. Okay, Natural log and e are inverses, so we're left with 2x equals natural log of 5/4, and then divide everything by 2. So my exact answer is going to be natural log of 5/4 divided by 2. Okay, so that's my exact answer. My approximation, again, I have natural log as a button, so I can enter this in the calculator. So we've got natural log of 5/4 divided by 2. So approximately 0.11. Okay, next problem here. Same thing, the 3 is the base of the exponential. I need to get rid of this 2 before taking a log of both sides. So I'm going to divide, because it's right now being multiplied. So I'm left with 3 to the x plus 1 equals 6. Now I'm going to take log base 3 of both sides to undo that exponential of base 3. Okay, those will cancel. We're left with x plus 1 equals log base 3 of 6. Subtract 1. So again, I'm going to put the 6 in parentheses to show that is the part that the log is applied to. And then minus 1 comes after. So exact answer, approximation. Okay, so log base 3, again, on my calculator, I don't have that log base on this model. So if you have it, you can just type in log base 3 of 6. If you don't, we can do what we did up in that previous example. I'm going to find, so log base 3 of 6. I'm just going to choose the common log and enter that. Okay, so we've got log of 6 divided by log of 3. Okay, and then we're going to subtract 1. So minus 1, about 0.63. Okay, so there's my exact, there's my approximation. And I actually think that was the last one. Yep, that is the last example for this video, you guys. So big idea, again, is to get the exponential piece by itself first before applying a log to get rid of it.